All right, so this is the last video for the slides on Unit 2. There's not as many this time, but there's just a lot of practice that we had to do. So last thing I'm going to talk about is accuracy, precision, and error. So accuracy is a measure of how close a measurement comes to the actual value. So how close you are to what it is. Precision is your ability to do that over and over and over and over again, or not necessarily be accurate over and over and over again, but just get the same number over and over and over again, even if it's wrong. So you could have a scale that doesn't work, it gives you the wrong number each time, but if you get that same wrong number every time, that's precise. So it's just how close a series of measurements are to one another. So to evaluate the accuracy, you have to know the correct value. To evaluate the precision, you cannot have only one measurement. You have to have two or more. So with these, the first one is accurate and precise because they hit the bullseye, they got the right value, and they did it 3 times. On this one, on part B, or picture B, they were precise but not accurate. They didn't hit the bullseye, but they did the exact same spot 3 times in a row. On C, they just stink. They didn't get the right value, or they didn't get the bullseye, and they were not consistent whatsoever. Now, if you wanted to see a dartboard of something that was accurate but not precise, what it would show is one dart in the bullseye, and that's one of those things where it's good to have both accuracy and precision because, you could blindfold yourself and get the bullseye once if you tried 1,000 times, but you have to be able to do it again and again if you want to actually be good. So we have to take both those into consideration when we're making measurements. Percent error, which is the calculation you do to show how far off you are from the actual value or the theoretical value. And the equation for that, you take the experimental value, and that's what you would find in a lab. So a block is supposed to weigh 100 grams, and you take it, or not weigh it, it's supposed to have a mass of 100 grams. You take the mass, and you find that it is 99 grams. Well, you would have to do 99 minus 100 because it's supposed to be 100. Then divide it by the theoretical, which was also 100 again. Multiply one by 100. Now, in that case, you're going to get your negative 1 divided by 100. You're going to get negative. You can get a negative percent error. What that tells you is that you are below what it was supposed to be. If you get a positive percent error, that means you are above what it was supposed to be. Both can happen. If you do a chemical reaction, you're expecting a certain amount, and you get above that, that means something else happened. Either you sneezed into your stuff, you created something you didn't intend to, you got some residue somewhere, there's all sorts of stuff. You can end up high or low. Sometimes I've seen people that like to put the absolute value around this, but the positive or negative actually does tell you information, so I like it. I like being able to see positive or negative. So on this one, you have a boiling point of 100 degrees Celsius for water, but you in lab find it to be 99.1. So this is what you would do. See, this one, they inserted the absolute value, which I don't do. You work it out, you get 0.9%. Now, actually, you would get negative 0.9%, which means you are below the correct value by 1/10 of a percent, which honestly, that's pretty good. All right, so looking at these, you have two sets of students. If the block was actually 5 grams, looking at this, which set of students was most accurate? Well, set 1, one of the students actually got it right. But set 2, notice, is way more precise. They're doing the same value over and over and over and over and over again. So set 1 is so jank. How are you supposed to deal with that? Like, what are you supposed to glean from that? If you know that it's supposed to be 5 grams and you're getting all these masses, we can actually take the scale and adjust for the mistake. So we can turn this into 5 grams. But this, we don't even know what to do with set 1. So precision is great. If we are precise, we can make adjustments so that it can be accurate. If you're neither accurate nor precise, it's really hard to do anything with it. All right, I think that's it. So just a lot of practice on this. If you have questions, feel free to email me. I will answer. Anyways, hope you learned something.